Hello, everyone, and welcome back to Intro to C course MCS 1142. Today is week 2A, which is second week, first session, which is the third session in total of semester 2021 summer. So today, and according to the syllabus, we will be going over chapter 1, and we will be assigned our first homework. So I will get back to this homework later this session. Let me go ahead and open the syllabus. So according to our syllabus, we will go over chapter 1 and homework 1. Chapter 1 is Introduction to Computers, the Internet, and the Web. After this session, once you are done with chapter 1, you will be covering basic computer concepts, different programming languages, the history of the language you are learning, which is C. Then you're gonna learn about the libraries in this language and the basics of object technology. And finally, a typical process or development environment, what happens when you click on this button from A to Z. With that being said, I'm gonna go ahead and start with the chapter. It would be helpful if you have the book in front of you because we're gonna be going like the book does it, starting with the hardware versus software, and then we go all the way to typical C program development environment. So the first topic in this chapter is hardware versus software. Computers in general can perform calculations and make logic decisions faster than a human being. Today, for example, the technology allows computers to make billions of calculations in less than 1 second. And we can demonstrate that by going to and doing a simple research on Google. For example, type anything like car. When I type that, it took less than a second to retrieve, look how many results in this time. So that would take a human being a lifetime. So some computers today are doing maybe trillions of instructions per second, and we call those some supercomputers. This is a supercomputer. This is not a regular computer like the ones we work on a daily basis. So how does a computer do it? Well, computer processes data by following sequence of orders or instructions, and that sequence of orders or a group of instructions are called computer programs. These programs will guide the computer through the instructions in orders. So it will guide the computer on what to do from top to bottom. If you have a program from top to bottom, first do this, first, second do this, then this, then this. So it's a list of instructions that are in order, and they will guide the computer on what to do. Those instructions are eventually specified by people. Those people are called computer programmers. Whoever types codes or instructions for the computer is called a programmer. And programs that run on a computer are referred to as software. So a piece of software is not physical, is not something that you can touch or sense, unlike hardware. Hardware is everything that you can touch in front of you. Hardware is the physical computer, which by itself consists of other different physical components. Example, my computer has a mouse, has a keyboard, has a screen, has hard disks in it, motherboard, CPU, a hard drive, etc. So this is the topic for hardware or software. Everything written in codes through instructions is called software, and everything physical is a hardware. With that being said, I'm gonna add a discussion for you to participate in, which is, in today, which one do you believe is cheaper? Is it hardware or software? What is cheaper for you to get? I'm gonna create that discussion on the syllabus, and you guys can go and add your opinion on the matter, and it will be graded as participation. Now, this is the topic for hardware versus software. The next topic in this chapter is called Moore's Law. Moore's Law is a law that was uh, put in place by Gordon Moore, who's the co-founder of Intel. You know, Intel, the company that makes CPUs. You know, you have an Intel i7, i9, 99000K, etc. So the co-founder, one of the founders, a co-founder called Gordon Moore, he identified a law back in like 1960s, and it was named after him. So what is Moore's law? Moore's law is a law that says computing power is dropping dramatically. Um, well, let me put it in a better better sentence. It is doubling the capacity of computers for the same cost with time. So every year, for the same cost, we are getting double the capacity. For example, last year or last 2 years, uh, you were able to get, let's say, a graphics card that is 4 GB for your games, and you paid $1,000. Today, for $1,000, you get double that power or double that capacity. And you can see that especially in hard disks. Like last year, 1 TB was $40. This year, 2 TB are for $40, and it is dropping dramatically. That's because of the development in both hardware and software. So computers that needed large rooms and costed millions of dollars, like 40 or 30 years ago, are now being put on chips that are smaller than a fingernail. And they cost maybe only a few bucks each. Each chip is very cheap compared to 30 years ago. So for many years, we have witnessed costs of hardware falling every year or two, and you can tell maybe from your own experience that every year or two, the capability of computers approximately doubled, and that was for the same cost. Again, like graphics cards, like hard disks, also in communication field, like transmission, like an antenna that transmits 1 gigahertz per second, let's say, or downloads 1 GB per second. It costed X dollars. Today, for the same amount of dollars, you can get an antenna that downloads 2 GB per second. And that was basically Moore's law that he put in 1960s, and it turned out to be true until today. Next thing you need to know from this chapter is computer components. So what is hardware, what is software, what is Moore's law, and what are the components of a computer or computer organization, how the book called it. Now, computers are divided into uh, different logical units or sections or components. You have an input unit, you have an output unit, you have arithmetic and logical unit, you have central processing unit, and you have secondary storage. I think they have it in the book. If you have the book in front of you, you would want to open page 4. So input units, they start with input unit. What is an input unit? It's any component or a device that sends data into the computer. So it's an input to the computer. An input unit could be keyboard, mouse, a scanner, or the microphone I'm talking to. So the microphone is sending data into the computer, then the computer is taking it and transmitting it, or basically storing it in this case, because it's not a live meeting, sorry. So that those were example of an input unit. What are some examples of output unit? Any unit or device or component that sends or transfers data from the computer into the outside world. For example, a screen. A screen displays data to me, or a speaker plays music, or any like LED light that blinks. You know, some computers don't have a screen; they have a light effects. So they blink red if something is wrong. They blink green if everything is okay. Also, a printer can be an output unit. A printer prints data to the outside world from the computer. Then we have memory units. Memory units are like RAM, and this is the live memory, not the storage memory. The main memory, for example, RAM, random access memory, which is a volatile, and I'll explain that in a second, is the live memory. For example, right now I opened this browser. This browser now is running on a RAM. It's not running from the hard drive. It was loaded from the hard drive. So when I close this, now there is no Chrome. If I click on Chrome and I executed, the computer will load it from the hard drive and put it on the RAM, put it on the main memory. It will load it from the secondary memory and put it on the main memory. And its main memory are called random access memories because the computer can access them in a random fashion. Remember how we said it's sequential from top to bottom? With with the storage and especially RAM, it's randomly accessed memory. So the CPU or the computer can access line 19 first, then 26, then 14. So it can access any memory in that sequence of memory. So that's why it's called random access memory. And it's called volatile for the reason that it loses its data when you shut it off. So right now I have this computer running in front of me. If I shut off my computer, I'm gonna lose this session. Visual Studio will close, Chrome will close, and if I run it back on, I'm not gonna find those sessions anymore because everything was erased from the random access memory or from the main memory. So remember, main memory is RAM, random access, and it's volatile, means it loses everything when you shut it down. Then we have the secondary storage. The secondary storage is, in this case, the hard drive. It is where we have long-term, high-capacity warehouse, if you want to call it warehouse. It's a place to store data for a long term in a high capacity. For example, you might have programs that are not actively used for years, but you can still have them in your hard drive and then you can execute them at any point in time. And secondary storage units are non-volatile, means if I shut down my computer and I run it back on, I will always find the data in that unit stored. Even Windows operating system is gonna be stored right there. So when I click on the button, when I click my hardware on the power button, the computer is gonna go to my storage unit and load Windows first, then Windows will load everything else for me. Then another component, so far we covered input units, output units, secondary storage, right? Input unit, output unit, sorry, main memory, and secondary memory. Then we have 1, 2, 3, 4. Then we have arithmetic and logical unit. It's called Arithmetic and Logical Unit, ALU, which is responsible for making all the calculations and computation, like addition, multiplication, division, etc. But in today's computers, ALUs are built inside the CPU shell. So you know how a CPU looks like? CPU. So this is a CPU, Central Processing Unit. In today's computers, an ALU is built inside CPU. With that being said, now we go to the CPU, which is a component. So inside this, there is a central processing unit, and this is the shell of it. This is a shell. Inside that shell, you have the CPU and the ALU. What is a central processing unit or a CPU? CPU is like the boss, or more like a manager, not the boss. It's the administrator that coordinates and supervises all the operations in uh, in uh, other components, or from other components, or to other components. CPU basically will tell everyone or every other component everything, what to do and when to do it. For example, it will tell the input unit when to read. It will tell and administer the output unit on when to display. So when the mouse clicks a button, the CPU will control and manages that input, and then accordingly do some task or do some process or execute some instructions, and then maybe route the output to the output unit. So far we covered CPU, which is this, main memory, which is a RAM. This is how a RAM looks like. And today they have like those RGB fancy colors on them that you can control. You have secondary storage, which is uh, like a hard drive, like this. This is the old one. What was it called today? Today, most popular ones are SATA. Uh, what was it called? There was a called. So if I say SATA versus, it will show me. SSD, yep. So today the SSD, and then um, it was called. It had a name. Sorry, I forgot it. SATA, SSD, NVM. Maybe it was the NVM. There was SATA. This is SSD, which is today's solid state drives, and yeah, HDD. Yep. So those are old. The newest one is SSD. Then you have input units, like we all know how a mouse or a keyboard look like. So this is a mouse, right? And the output unit, like a speaker that has a a auxiliary wire going into the computer. Now, with hardware being explained, we need to explain some of the software components. Let me open Paint in this case, and the topic in the book calls the data hierarchy. So data hierarchy, like the ranks of each of a data item or a storage unit. And this section basically tries to explain to you how data is stored in computers. We start from smallest to largest. The smallest is called bit. Smallest. Actually, let me do it like this. So the smallest is a bit. Bit. What is a bit? A bit is the smallest data item or a storage unit, and it can carry only one value. So the definition is can carry only one value, either 0 or 1. You can imagine it as a switch with on or off. So a bit either 0 or 1. It's either activated or deactivated. It's either uh, 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 on and off. Basically, this is the best representation that helped me as a student remember it. It's a switch that is either on or off. Then we go to the next larger uh, data item, which is a character. A character is 1 byte in size, which is 8 bits, and you need to remember those. A byte is equal to 8 bits, so it's 8 switches that are either all off, or some of them are off, or some of them basically on, which is the same, or all of them are on. So you're gonna have 8 bits, so 1, 2, 3, 4, 1, 2, 3, 4. This is one value. Then this is another value. If this switch is activated, it's different than having it deactivated. So you have this value that represents some character. Let's say this represents A. Then you have another value that represents B. Then you have another value, which is this switch being activated. Now it's C. Then I have another value, which is both last 2 switches are activated. So now it's D. So each combination of these switches being on or off represent a character. That gives me 2 to the power 8 choices. Why 2 to the power 8? Because this is complement of 2. I can only have 2 options on this and 2 options on this, 2 options on this, because it can be only 0 or 1. So 2 times 2 times 2 times 2 times 2 times 2, 2 times 8 options. And this is represented by what's called ASCII code. So ASCII code, sorry, is a table that represents all the values that you can find in a character. So based on a decimal value, because 2 times 8 is so minus 255 to plus 255, so 2 power 8. Two power 8. Here it is. 256 options. So from 0 to 255, because 256 options, I can always start from 0, and actually computers always start from 0. So the first option is having them all zeros. So this is an option, then another option, then another. So from 0 to 255 is 256 options. So this is the representation in binary. This would be the representation in ASCII, but I'm gonna strip it out for now because we want to go by the table. But I want to show you the representation as decimal. Each of this binary representation equals a value in decimal. So again, because these are power of 2 and this complement of 2, then this is basically the value 1. And then this is the value 2. Then this is the value 4, 8, 16, 32, 64. So this bit has this value, 64 in decimal. This bit has this value, this bit has this value, this bit has this value, and this bit has this value, then this bit has this value. One more. Oops. So this is for this, this is for this, this is for this, this is for this. So, oh, why? Why you do this? So, hopefully this is clear on the screen. So if any bit that is activated, that its value will be considered. For example, in this representation, 0, 0, 0, 0, 0, 0, 0, 1, 1 means take the last two values and add them together. So in this case, the representation for this binary is 1 plus 2, means the 2 to the power 1 is activated. The 2 to the power 2 is also activated. The 2 to the power 0 is not activated, and so on so forth. So 2 to the power 0, which is the last bit, is 1. Then the 2 to the power 1 is 2. So the value, the decimal value of this representation is equal to 3. Another representation would be having it like 1, 0, 1, 0, 1, 1, 0, 0. So those are 8. So I'm gonna do it again like this. This is here, this is here, this is here, this is here, and this is here. So what is the representation of this? The representation of this is telling me this is not activated, so I don't want this. This is not activated. This one is activated. This one is activated. This is not activated. This is activated, not activated, activated. So the representation of this is 128 plus 32 plus 8 plus 4 equal, you do the math. So this has a decimal value which is equal to the sum of these numbers. So with that being said, I'm gonna go back to the ASCII table. So notice how we said each representation has a decimal value. In this case, this represents 3, this represents 0, this represents 1, this represents 2, this represents 3, this represents this number. So this is the ASCII code. The binary that evaluates to decimal equal to 0 is a null. Null means nothing, nothing, like emptiness. If you have a placeholder in your code and you don't want to store anything in it, you don't go and store 0, because 0 is something. 0 is not nothing. 0 has a value. So if you want a variable that has nothing in it, you store null in it. And those are similar. So I'm gonna similar, but too much details. I'm not gonna go over them. I want you to start from 33. Why? 33 is like more a human representation. When it comes to characters, which is the one next to bits, characters can carry many different symbols. These symbols can be decimal numbers, can be letters like alphabet A, B, C, or smaller case and uppercase like capital letter or small letter. They can have symbols. Um, so starting with the value 33, it's an exclamation mark. This character is this bit representation is this, so it's a map. Now notice the bit representation that evaluates to 48 is the decimal character. So this is the shape 0, not the value 0, so you don't want to confuse. This is the shape 1, not the value 1. So the shape 0, the shape 1, the shape 2, the shape 3. So in my program, if I pass it a representation like on a very low level, if I pass it a representation that evaluates to 48, it will display the shape 0 if I'm writing binary. Then we go to the value that represents 65 is A, then B, then C, and those are capital letters. Then we go to 97, small letters, then some symbols, then some other symbols, etc., 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 to reach 255. So from 0 to 255, all the combinations of active versus inactive gives me all the possible values or shapes that I can store in a character variable. So anytime I create a character, I can store any of those representation. In other words, any of those shapes. The next one is, let me remove all these. The next data item that we can store data in, which is a field. So a field is basically a group of characters. So group of characters or bytes in this case. Why? Because each character is 1 byte. So a field is a group of characters. For example, my name. My name is a field. My name is a group of characters. I have this 1 byte, 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 this 1 byte. They form a field. Remember, each 1 byte is 8 bits, and you need to remember those. The next larger is called record, and the record is a group of fields. Sorry, excuse me. So a record is a sentence. Then the next item is, in this case, file, um, database, big data. That would be like the largest. So files are like a paragraph, group of records, paragraph. Database is eventually, um, today most popular databases are called relational database, and they are basically tables that have relations with each other. So you have a table that says, okay, student ID, student name, student last name, student age, student address, student address, student phone number. Then you have another table that has like some demographics, where what cities have most influence in your, for example, school. So you have a table that says this address has this weight, this address has this weight, this address has this weight, and then those addresses in one table are related to the addresses in another table from the student table. Remember how each student has an address? Then each address has a weight. So all tables are related to each other, but anything can be a database. Any file can be a database. Anywhere that you can store data is called a database. So you have one paragraph, then you have group of paragraphs, etc. With that being said, these are the different data items that you can store data in, and this is the hierarchy. The bit is the smallest, and big data is the biggest. Now I want you to go over, let me see which page was it. It was page 7. In page 7, figure 1.3, I want you to look at byte measurements. So 1 bit, then you have 8 bytes. Then what is a kilobyte? What is a megabyte? What is a gigabyte? What is a terabyte? And I want you to notice that there is always that extra 24 uh, addition. So how many bytes in kilobytes? And notice it is no, this is not true. Digital storage, data transfer rate. No. Mm, digital storage. No. 1 byte. 124. No. It's kilobyte. It's 1024. Therefore, 1 kilobyte is no. This is not correct in computer science. So this is the correct. Why that one is showing me wrong? People also ask. Kilobyte is 1024 bytes, not 1000 bytes as you might expect. Why? Because computers uh, store in a complement of two. So if I go back to my paint, you have 2 power 0, so 2 power 0 is 1, then 2 power 1 is 2, then 2 power 2 is 4. So notice how it's always doubling. So double, 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 256. Remember the RAMs? RAM, they used to come as 256 megabyte. Then they started coming as 512 megabytes. Then they started to come as 1 gigabyte. But in our case, since we are starting with bits, so this would be 24. So this would be a kilobyte. Kilobyte. Kilobyte is 1024 bytes. Every byte is 8 bits. But starting from 1 byte, kilobyte, then we move on. We move on with uh, same case for megabyte. So now when I reach a megabyte, it's gonna be it's gonna have that extra value at the end. So a megabyte is not 1 million. It's 1 million and or 1000 in this case. It's 1000 and something. I don't remember right, but let's see how many kilobytes make a megabyte. No, you go away. Megabyte in computers. How many kilobytes in megabyte? Oh, go away. Here. 1024. Now 1000 megabytes is this is a good representation. Actually, I could you could I think I'm wasting more time than expected on this because it is on in the book. I'm trying to put it in front of you, but it is in front of you. But it's in the book on page 7, figure 1.3. How many kilobytes in a byte? Da da da. So I'm not gonna waste more time on this. Let me know if you have any questions. So why it's always a complement of two? Because this is how computers store it. So computers are always complement of two. And this is the data hierarchy. So I'm gonna move on with the book. The next topic is machine language, assembly language, and high-level languages. So there are different programming languages, and they are categorized. There is languages that are machine language, there are languages that are assembly language, and there are languages that are high-level languages. Sorry, excuse me. So machine language is specific to each computer. Each computer has its own machine language, and each computer understands its own language. And that language is basically defined by how its hardware is designed, right? Because I don't know if you know, but you know how sometimes you see Windows 64, most of them right now are Windows 64. You might see on your computer operating system, like if I go and say my computer properties, notice how it tells me 64 based processor. So this hardware I'm on is x64 based processor. So it's designed to be 64 bit long. So on the motherboard, the cables that transfer data between each component are of 64 lines. You have a it's called a bus. You have a bus with 64 small wires. Each wire represents one bit. So each wire will pass either 0 or 1. For example, imagine I have 64 here, and this component will pass to this component 1 0 0 1 1 0 0 1 1, etc., up to 64. So 64 small wires that will pass either 1 or 0. Now this system only understands a machine language that is based on 64-bit. This machine is not going to understand a language written as 32 and other stuff, and this is just a very high level to prove the concept. But every machine understand its own language that is defined by the design of the hardware. It's however the hardware is built. Then we go to assembly language. Assembly language is is a little more clearer to the human being, right? Like ones and zeros are not clear for a human being to understand. If you have a paragraph of ones and zeros, it's not going to be very clear on what does it mean exactly. So assembly language are a little clearer uh, to the human language. And it is like this. So you can have, for example, a variable that has base pay, right? Base pay equal 1000. Then you have another variable that says overpay for overtime, and I'm going to say 100. Then you have uh, gross pay, which is the result of the two. So how do I do that? I say uh, bring, or what I'm trying to say is get it from the storage unit, whatever your unit is, load base pay. Then I'm gonna say add overpay. Then I'm gonna say store gross pay, and this is simple language, simple representation of the language. So this is the language. It's more clearer than ones and zeros, but still, if you have 1000 variables for many employees and different functionalities, not just adding overtime on base pay, you want to do more sophisticated operations, it's going to be very confusing for a human being. So then they invented high-level programming languages. High-level programming languages like C. So those languages that have some English in them. This is C++, but they have some English in them. You can say, you can tell string. You know what string is? Using. You know what the word using means? Transform. Char, unsigned means it doesn't have a sign. Return, so it has English to it. Even if I'm looking at, let me show you. Even if I'm looking at thousands of lines of code, so even if I'm looking at thousands of lines of codes, I can tell, I can still understand. I'm not gonna have hard time, especially when I'm organized, right? So that's where high languages come. They were they were invented in order to speed up the programming process. Because imagine yourself writing zeros and ones or writing this. It will take you a century to write a program, unless you have like 20 guys with you writing the same program. And with the right coordination, then you can build it in a much faster time. So those languages, high-level languages, they were built to speed up the programming process and make it easier for humans to build programs, basically. But they still uh, require translate. They call it translators or interpreters. Interpreters are for script languages and compilers for object-oriented languages. Those both interpreters and compilers are translators. They translate this language to this language, to the ones and zeros, to the machine language. Notice in Visual Studio, I have my target. I'm telling it I want a debug, and I'm targeting 64 uh, machines, 64 based machines. So the compiler in Visual Studio will take this code and translate it to ones and zeros instructions for a 64 hardware processor, hardware, well, 64 based processor in order to execute those systems. So this is the topic that is in the book. It's the difference between machine language, assembly language, and high level uh, languages. Now the book next goes to history of C. Like they want you to know some of the history of this language that you are trying to learn, and it's simple, really. So I'm gonna go ahead actually and start typing here because it is a better interface for you guys to see. So C, what is C? C was bait, and this is how you write comments or this. So this is for one line, this is for a paragraph. And we can see, we're gonna go over all this syntax. So C evolved uh, from two previous languages. They are called LB, actually B, C, B, L, and P. Those two languages were like the ancestors of C. C was based on them. Now, BCBL was developed in 1967 by a guy called Martin Richards. And this was used for writing operating systems and compilers, actually, and compilers. Then you have the B, which was developed in 1970 by a guy called Thompson. And he did it to, he developed that language to create Unix systems. So Unix is like a competitor for Windows. It's an operating system. It's the mediator between you as a user or a software and the hardware. So between me right now and the hardware on my computer, there is this operating system which is called Windows that is controlling everything under the hood, showing me things, and on the other hand, at the back end, controlling the wire, what goes through the wires to the uh, CPU to execute. So that's the job of an operating system. So why C? C was built for performance, basically for speed. They wanted a high level language, uh, has good readability uh, for the human, and it's fast, and and then C became widely used to develop systems that demanded performance. Any system that said, hey, I want to write a program that is very fast, they had to use C. It was their best option, such as operating systems, such as embedded systems in like microcontrollers you see in the cars, or real-time systems, anything that requires real-time, and communication systems, basically. They are all written in C because it's fast, it's high level, but still fast enough. So it's like one of the fastest high-level languages. And because C was independent of the hardware, it was widely available. So applications written in C can run on range of computer systems without a lot of modifications, right? You don't have to modify the code in order to run it on a different system. And this is right now a problem. If you write an application for iPhone, it's not gonna work on Android. You might need, if you copy the code and paste it, you might have to you have to you to in order to make it work, you have to change your code and make modifications. So what is C? This is the history of C. Then they want you to know C standard library, which is on page C standard library, which is on page 10, section 1.6. Why they want you to learn about this? They want you to learn about this because they want you um, to know that when you are programming in C, you will typically use building blocks. Basically, you're gonna use the same. You're gonna approach every program systematically using libraries, using functions that you create or functions that other people created. Of course, other people that you trust. You're not going to download some software or any executable or any library and use it. It might be hacking your system. So you're going to use libraries, you're going to use functions written by you or by others that they created and made it available for you. Of course, you're not going to steal. So so with that being said, functions, you're going to learn them in chapter 5, so we're not going to focus a lot on them. But every C programmer consists of pieces called functions. Now in C, we can program all the functions we need and then basically form a C program, build our program. But most of the C programmers right now do not build everything from scratch. They in fact take advantage of a bigger collection of existing functions, and they are built by someone else that provided it to them. Those can be found in the C standard library. That's why they want you to learn about C standard library. Why? Because you always want to reuse code. You don't want to build everything from scratch because it's going to take you a lot of time to reinvent everything. You don't want to reinvent the wheel. Instead, you use existing pieces and save development time and code maintenance. You can't imagine how much hard it is to build a piece of code and then go over that piece of code to make sure it's bulletproof, it has no bugs, it doesn't crash the system, etc. And this process is actually called software reuse. Now there is advantage and disadvantage for each approach. If you want to write your own functions, the advantage of creating your own function is that you will exactly know how they work. You will know every line, what's meant by it. It's going to be your handwriting, of course, code handwriting, because every software developer has his own styling. So the advantage is you're gonna know exactly how it works. You will be able to examine the code because it was written by you. Now, the disadvantage is the time-consuming effort that goes in designing and developing and debugging new functions. Now, for this approach, or building your own advantage and disadvantage, for the opposite approach, which is reusing from the standard library or other library, the advantage is that instead of writing your own version of functions that can improve program performance, you use someone else that were written more efficiently. In order for you to have it provided, in order for the library to be provided for you, this has been gone through a lot of tests. You know how many developers built and tested and verified that this code is bulletproof. Right now, I'm sitting here. I know some about computer science. You know some about computer science, but there are people who have like 3 4 PhDs in computer science who built these functions. So of course I would be lucky to use them. So why not use them? I know that it was built by a professional, so I'm sure that it is fast, it is bulletproof, there are no bugs, and it is modular. It is consistent. It's consistent for the same input. It always gives me the same output. There is no way I give the same input and then gets a different result. It's consistent. Now, this is an advantage. Um, Another advantage is if you write a code using standard libraries, you can literally copy, paste it somewhere else, and it will work. Why? Because it's referencing the standard library. It's referencing the same source of code. But if you write your own, everything is your own, and then you copy a piece of code and you paste it somewhere else, you have to copy all those libraries with it. So it's like a full package. This is an advantage of reusing. Another advantage or disadvantage may be complicity, being complicated. Like if you want to step through this code, it's going to be complicated because it's not your code. But why would you step into this code? It's not going to be broken unless you want to change it. If you want to change it, then you're going to be looking into it under the hood. What does it do? And then changing it. You can actually do that. You can do that, but again, it will not work somewhere else. This is what they wanted you to know. They wanted you to know and use standard library because it is the rule of thumb to reuse the code, existing code that is verified. The next section is they wanted you to know about C++ and other C-based languages. So all other languages that are based on C. And there is a table on page 11, figure 1.5, for all many, for like six or seven programming languages, and where is each language being used right now. You have Objective-C, you have Java, you have C#, you have PHP, Python, JavaScript, and Swift. All these languages are based on the C. And they are used, I can tell, in many other fields and concentrations. So if you, so why we are learning C? This is why. Although it's old, but this is why we are learning C. We are learning C for the fact that it is widely used. And if you know how to program in C, you're going to be able to learn uh, many more programming languages because they are all based on this language. For example, like driving a car. If you learn driving a car that was made in the 1980s, it's going to be relatively easy to learn how to drive a 2020 model. Of course, there is all this fancy electronics, but it's going to be easy to translate or convert from 1990 car to 2022 because you know how to drive a car. So you still need to get familiar with the options, with all the options with the 2020, but you have the basics, you have the background, and you can drive it. This is why this is why you are learning C. And what is C++? C++ is the main and this C++. The main and most popular language that is built based on C. Out of all the languages, C++ is the most popular, and this is why it's called C++. It's plus plus. It's an addition on C. What is C++? C++ is a cross-platform language. Cross-platform language, it means it works on many platforms. It's not like specific to one platform like Objective-C for iPhone, or maybe Swift for iPhone. It can be used to create high-performance applications, especially like game engines. It was developed by a guy called Yarn or sorry, Yarn or Jarn. It depends where are you from. from 1979 actually to 1998. So it took this much time to be developed. It was an extension to C language. It gives programmers a high level of control. You literally control like even all the way from a memory address to the screen. So you see this range of levels between the machine, between the hardware, all the way to the human. So you have a wide range of controls. You can control the binary up to the screen, and it's fast. It's fast, very fast, fastest maybe. And the language itself, C++, was updated majorly. It had three major updates: 2011, 2014, 2017, and it's called C++ 11, C++ 14, and the newest is C++ 17. Why would you use C++? You would use so what is C++? Like we answered, what is C? Why is C? So now what is C++? Why C++? Why? Because it's the most popular programming language, right? Because if I go on Google and I say C++, I'm gonna find a lot of popularity and familiarity and people trying to teach me about it, showing me examples, etc. So C++ is very popular, used everywhere. C++ can be found working in many operating systems, many graphical user interfaces, many embedded systems. So it's not just knowledge out there. It is in the field. If you go to the field, you're gonna see that, hey, do you know C++? We use C++. C++ also, why? Because it is object oriented, meaning it reflects real life situation, because everything in real life is based on objects. It gives a clear structure for programs and allows code to be reused. So you build an object and then you need this object somewhere else, you just reuse, you create an instance of that object. And you're gonna see more in computer science 1, maybe computer science 2, not 1, where you start learning mainly about objects and the classes. And again, reusing is saving on development. Anywhere you can reuse a code, you're saving money. You don't have to rewrite it again. And why C++? Another advantage would be portable, maybe portability, because I can target many platforms, right? So that's very good. I don't have to switch platforms in order to write another. In order to write the same application, I write code once and I build it for different mobiles, for different computers. Another one, it's fun. Really, it's fun to work with. It's fun to learn. It's everywhere. Like if I go to Stack Overflow, C++ is maybe one of the best. Let me see. One of the like most. How do I see it again? Where are you? Let's see. C sharp. How do I go? They always change it. Tags. Yeah, here tags. So if I say popular, C++. Wow. Mm, C sharp. Maybe because of the hardware power nowadays. Like computers are fast when it comes to hardware, so C++ is losing rank. It has this number of questions. But again, this is still popular. If you need help with C++, you will find help. So it's easy to learn, fun to learn. And C++ is very close to the rest. Like if we are looking at the top 8, oh, C sharp is here. Well, C sharp is based on C++. So if I learn C, it's easy to learn C++. It's easy to learn C sharp. Notice C sharp is two pluses, two additional pluses. So you start with C, and then they added stuff to it, and then they added stuff to C sharp. So now it became C hash, which is C sharp. So yeah, basically. The last thing we need to go over is typical C programming, like what happens when when we click this button, but I'm gonna keep it for the next session because chapter 2 is relatively easy. Now chapter 1 and 2 and maybe 3 are mainly knowledge. There is no coding in them. So I'm gonna leave the knowledge for the next time. What I want to do right now is walk you through the homework really quick. I'm gonna post this right now, and let's see again where were we with the syllabus. So this is due maybe next week. So homework one assigned May 27, homework one due, so it's due in 2 days. I might change that just so you have 1 week. Let me see. But for now, it's due 2 days. So by next session, you need, because it's very easy, really, homeworks are very easy, and you have me, so just shoot me an email. Just be committed, be committed, and you will score uh, the grade. So all I'm asking is build a program that prints out your full name and then your opinion on how many computers do you think you use today. How many computers you think you use today? Now remember, computer is not just a desktop or a laptop. Everything is computerized now. Mobile phone is a computer. It might have three computers in it, not just one computer. Your car, can you guess how many computers is in your car or are in your car? Have you used the ATM machine today or a credit card machine? So this is the homework. I want you to build an application. Remember we did Hello World last session. So I want you to build similar application and I want you to print a sentence. Now in your code, I want you to write the code and comment each line. Tell me what does this line mean? Me like now include stdio. I mean use the built-in file that is named stdio, which is provided by the language inside this current file. So this is what this line means. Then I want you to zip your CPP. So remember how you created your file? You can go here and say open folder in File Explorer. When I open this, it's going to open me where the solution is located. Then I can pick the CPP and I can say send to compressed. So I want you to compress that file into where is homework? So compress that file into a zip file and then give it your name and which homework. If you submit a file that has no name and it's very confusing which homework is this, you're gonna lose the grade. And I'm gonna type it right here right now. Because like when you have a lot of students and you try to filter and you don't find that homework, it's very very annoying really. And on the other hand, it's very easy for you to do. It's very easy for you to just put your name and which homework is this for you to submit your homework in this format. So this was it for this session. Hopefully you guys enjoyed it, and see you next week. Please make sure you prepare and go over the discussion page with the discussion I'm about to post, which is which uh, which one do you think is cheaper, software or hardware to make to build? Thank you so much.